So for this chapter, which I called Primitives and Components, so chapter 3, let me just begin by trying to clarify some of the names, the concepts that A-frame uses. So here I'm using the concept of primitive, which is something that A-frame uses. A primitive in A-frame is basically represented by an HTML element. So sometimes I call these elements, sometimes I call these primitives. Actually, A-frame has another name for this, which is an entity. So an entity in A-frame is also represented by an HTML element. But in A-frame, an entity represents anything that we can include in a scene. And that's most often a 3D object, but not always. There are entities in A-frame which are not represented as a 3D object, which don't have a visual representation. So 3D object, primitive, entity, element, I'll use all these names to refer to the same thing. They are different things in A-frame and HTML, but for now the distinction is not very important, okay? So when you hear one of these concepts, just think as something that we can include in a scene and has a visual, some kind of visual representation inside that scene. So we can start by seeing some of the most basic primitives, most basic 3D objects, and we already saw some of these. So for example, a box, a 3D box, a sphere, a cylinder, a plane. There are additional primitives in A-frame, and I'll show you the lists very soon. We also saw already that for each primitive, we can further refine how it looks. We can specialize each primitive by telling A-frame where in space it should be located. And I'll explain in a minute how we position things. We can tell its size, and different primitives have different ways for us to specify its size. So for the box, we need 3 dimensions: the width, the height, and the depth. We can also tell A-frame how it should be positioned in the scene. So what perspective the object should have. And this is done by saying what rotation the object will have inside the scene. We can also specify the color, and we will see further on, we will see additional characteristics that we can add to primitives. So again, an important thing to note is that different primitives have different attributes, different characteristics. So for example, the sphere, in order for us to specify the size of a sphere, we specify the radius. So we don't specify a width and a height and the depth. We just need a single attribute, the radius. Now, one of the most important, the most basic things in A-frame is positioning elements, positioning the objects. And you note that for the box in the previous example, the position had a value of 0, 2, -2. So what does this mean? It means that in 3D space, this box will be positioned in 0 for the x-axis, at 2 for the y-axis, and -2 for the z-axis. For us to understand what this means, we need to know what is the reference for A-frame. And so we need to know where the origin is. And in A-frame, we can think of the origin as being the point that is at our feet when we enter that environment. When we start an environment in A-frame, the user's feet will be at 0, 0, 0. So the user's feet will be positioned at z equals 0, y equals 0, z equals 0. And by the way, the user's head, at least in this mode, in desktop and mobile mode, the user's head will be positioned at z equals 0, y equals 1.6, and z equals 0. So basically, our head is at a height of 1.6 meters. So all unities, all values in A-frame are specified, all position and dimension values are specified in meters. One useful mnemonic that I use for knowing where the positive direction of an axis is this hand mnemonic that I'm showing you here in the screen. So if you place, it's hard to demonstrate this for the camera, but if you place your fingers like this, like you see there on the image, and you point your middle finger directly at you, then your fingers will be pointing in the direction of the positive values for each of the three axes. So your thumb will point in the positive X direction, your index finger will point in the positive Y direction, so Y grows upwards, and your middle finger will be pointing the position of the positive direction for the Z axis. So this means that if you place your fingers like this, you'll notice that Z decreases as it moves further away from you. So a negative Z is something that is in front of you. And that is why that, for example, in the box, in the first example, it had a Z of -2 to make sure that when you enter the environment, you'll be able to see the box. So it will be in front of you and not on your back. If you put something in a positive Z, when you enter the environment, it will be on your back. So you won't see it immediately unless you rotate or you move inside that environment. So this is very important because sometimes we position things and we load the environment and we don't see anything. Often that's because it's not in a position that we can immediately see. So we need to navigate the environment to find the object. So we already saw also that we can control the size of objects. And we saw for the box that we have 3 attributes to control that. Again, these values, width, height, and depth, they are in meters. And by default, if we don't specify, for example, if we include a box in our environment and we don't specify its size, A-frame will assign a default size of 1 meter. So if we don't say the width, height, and depth of the box, it will be a box of 1 meter width, 1 meter in height, and 1 meter in depth. And the same for the sphere, the default radius is 1 meter. So I won't go through this again, and the most common attributes for sizes are width, height, and depth, and radius. So most primitives just need these attributes. Another important thing, and it's also often difficult to get the first time, is the rotation. So we saw that we can position our objects in a scene, like in this one, but we can also rotate the objects, like this box. So contrary to the first example where the box was upright, in this case the box is tilted, so it's rotated. Now we do this with the rotation attribute that we already saw. So I'll show you the source for this example. So how is that box? How does it appear tilted? Well, basically we have defined the attribute for rotation and we specified the value 45, 0, 0. Like in position, rotation has three components. One for X rotation, so rotation along the X axis, rotation along the Y axis, and rotation along the Z axis. So it's in the same order, Z, Y, X, Y, and Z. Very important thing to know, rotation is specified in degrees, not in radians, in degrees, which is fairly intuitive. For us, it's more intuitive to use degrees than radians for rotation values. So basically this means that the box is rotated 45 degrees in the x-axis. As for the position, it is sometimes hard to know how things will rotate. And I often use also a hand mnemonic, which is the one that is depicted here in the screen. So the thing is, we need to rotate objects for each axis independently. And the important thing to know is what is the positive rotation for each axis. So when we say 45 degrees rotation on the x-axis, that's 45, that's positive value. But what does it mean? In what direction is the value positive for the rotation? An easy way to know that is by using this hand mnemonics. So if we want to rotate along the x-axis, for example, we can just point our thumb in the positive direction of the y-axis, and we know that by using the other mnemonic. So we know, I'm placing this in my perspective now. If I use the first mnemonic, I know that the x-axis grows to my right. So now I can use this second mnemonic to know the positive rotation direction. So I point the thumb in the positive direction of the axis that I want to rotate about. And as I close my hand, the movement that my hand does closing, that's the positive rotation axis. So if I rotate 45 degrees, then the box would be roughly like this in the x-axis. So it will be tilted with its top towards me. And that's exactly what happened here in this example. So the box was tilted, the top of the box was tilted towards me in the positive x rotation direction. Now this may take a bit of time to getting used to, so I suggest that you try a few examples and try rotating them along different axes so that you understand how this works. It's not difficult, particularly if you apply those hand mnemonics. Another characteristic that's very important to control is color, of course. And we already saw that color can be specified in different ways. I'll show you some of those. So, for example, we saw that we can just specify a name for the color, as in this first box here. I'm saying that the color of the box should be red. And I can say this, I can use the same approach for different colors. I can say that a box is green, or that a box is blue, or yellow, or black, or pink. So most common colors, they have a name. They have a predefined name in A-frame, and actually in HTML or CSS. So there are some predefined color names that you can use also in A-frame. Of course, there are colors that don't have a name. So if we want to specify an arbitrary color, then we need to use a different notation. And for that, the most familiar notation is this one. So in this way, in this notation, the color starts with a hash symbol, and then it has 6 characters. Don't worry too much about the meaning of these values. It's just important to know that we are actually specifying a color in RGB mode. So we're specifying the 3 components of color: the red component, the green component, and the blue component. And we're specifying, just if you are curious, this is an hexadecimal numbering system. So numbers, instead of going from digits, instead of going from 0 to 9, they actually go from 0 to F, which means 16 or 15 actually. So there are 16 different values, hence the name hexadecimal. But it's not really important because it's easy to get to these values by just using a color picker. In a web page, there are lots of web pages that allow you to select a color and then give you this hexadecimal number that you can just paste inside a frame. But so it's important to know that you can specify colors using these 2 main notations: the color name and an hexadecimal value. Just for reference, because I told you I would mention the list of other simple 3D objects that A-frame provides. This example here has the list. It includes all the simple 3D objects that A-frame gives you. So you see the familiar box that we already use, the cylinder, the sphere. You also see a cone, and here at the bottom there are more complex objects with more faces. And you see also here the donut and this weird looking object. And it is also possible to include 3D objects in A-frame that actually only have 2 dimensions, like these ones here at the top. So here you see a circle, a plane, a ring, and a triangle, which are actually not 3-dimensional shapes. They are 2-dimensional, but often they are useful also in A-frame. So this is just a complete list, and you can see the name of the element. If you go to the source of that file, you'll see the various names. So some of these have weird names, but you just need to copy and paste the element names. Also, an important thing that I'll just mention here and give a simple example for now, but later on we'll make use of this aspect of A-frame for creating complex objects, and particularly objects that move, that had some kind of animation. This will be particularly important when we get to animations. But just for now, just understand that just as we can in regular HTML, we can include an element inside another element. In A-frame, we can also do that. So for example, it may not make much sense in the beginning, so this may sound weird, but we can, for example, include a sphere inside a circle. This doesn't seem to make much sense, but it actually does. So what this does, visually, it doesn't create anything that we couldn't create otherwise without nesting the two primitives. So basically, in this scene, I'll just move around a bit. We have a circle. And if we move behind the circle, we don't see it. As I told you already, most primitives can only be seen from one side, but later on we'll see how to change that. So we have a circle and we have a small sphere with a radius of 0.1 meters. So of course we could have done this by just placing two independent primitives, a circle and a sphere, as we have done in previous examples. So why would we want to place a sphere inside a circle? Because when we do this in A-frame, not in HTML, it doesn't work like that in HTML, but in A-frame, when we place a 3D object inside another 3D object, we are actually creating a new reference for that inner object. So notice here that the position of this sphere is at x equals 1.5, and then it's 0 on the y-axis and 0 on the z-axis. And I'll open this in a new tab just to make sure that you understand what is going on. So notice that if we had just placed this sphere outside of the circle and we gave it this position, it would be at 1.5 meters to our right, and it would be at 0 on the y-axis, so it would be at our feet, and it would be at 0 in the z-axis. So it would actually be on the same plane that we would be. It would be to our right. So we wouldn't see it when we enter that environment. So what is happening here? Because we can see that sphere and we see that it is on the same plane as the circle. So basically what happened is by nesting the sphere inside the circle, the reference point for the sphere will be the center point of the circle. It won't be the global world reference of the scene. So this is useful because it allows us to position objects relative to other objects. So basically, we are positioning the sphere relative to the circle, relative to the center point of the circle. And in many cases, this makes it easier to position things because we can just say that the sphere is displaced from the center of the circle by 1.5 meters in the x-axis. And that's it, we have positioned the sphere. Another advantage, and I'll show you by editing the example, is, sorry, so it has to reload my editor. So I'm going to open the source code for that example. And another advantage is after we have positioned the sphere, so the inner object relative to the outer one, we can just move the complete set of objects by repositioning the outer one. So if I for example, I noticed that I don't want the circle here right in front of my eyes. I want it a bit higher. I can just change the position of the circle, and the position of the sphere will go along with it. So let's put this at 2.5 meters high in the air instead of 1.6. And I'll reload the scene. And it wasn't easy to see because I changed perspective, but it's now a bit higher. And we can even do this on the other axis to make it easier to see. So for example, let's put the circle 2 meters to the right. So you notice that the position of the circle changed, but the relative position of the sphere relative to the circle is still correct, because we wanted this to happen. We wanted a sphere position relative to the circle. So this makes it easier to position objects relative to other objects, and it makes it easier to create complex objects made up of simpler parts. And then we can just move the complete set, the complex object, by just changing the position of one single object.